Hello guys, welcome to the new video. Today we are going to implement a custom object detector using YOLO V8 models, and you will see how to very simply you can create a custom object detector on the custom dataset. So very first you just need to follow some uh, folder structure. For doing that, we are going to do this on the number plates. So for doing that on the number plates, we are going to implement a custom object detector. So first of all, create a folder. We are totally going to work on collab, so we are using Google Drive to store our folders. So first of all, I have created a folder named store. Then inside store, I have some files, and I have a data folder. Inside data folder, you have to follow this folder structure because YOLO V8 go and take files, images, and labels from this folder structure only. So inside data we have labels and images. So inside images you can see validation and training images. Inside training image folder, we have images which we are going to use for training. Similarly, in labels, we have train and test labels, train and validation labels. So, as you can see, our label files are stored properly. So, yes, our folder structure is complete. So, let's move further. You have to follow the same folder structure when you are going to work with YOLO V8 models. Let's go to our jump into our collab file. So, for let's start our project. First of all, we have to mount our Google Drive. Then simply type from Google dot collab import drive dot mount content slash drive. So this is the code to mount our Google Drive. Simply write the code and press Control plus Shift plus Enter. So yeah, for doing this project, we are going to use T4 GPU. So I'm going to change my runtime. So after running this code, you will get this kind of notification. Simply click continue. So I'm going to change my runtime today for GPU because we need GPU, because with GPU it will be very beneficial to process our training part, else it will take so much time for training of the model. So yes, let's deep dive. So after that we have to give root directory. So simply the path of our data, simply press root underscore dir, then click here, and our drive will be mounted here. If not mounted, then click here, it will be mounted in no time. Yeah, you can see now our drive is mounted. Just locate the path to the data folder, then right click, copy the path and paste it here. Shift enter. Now if you haven't worked with YOLO models, then you have to install the Ultralytics library. Simply do pip install Ultralytics. It will collect packages. After that, we are going to we are completely going to do hands-on tutorial in this video. So after that, we are going to simply import Ultralytics. From Ultralytics, import YOLO. That is the way you can import YOLO models. From model, we are going to import we are going to create a model from scratch. So this is the way you can create a model from scratch. We are not going to use a pre-trained model. Only we are not going to use a trained model, but we are training our own model. So simply type like that, and here is for nano version, and you have to type .yaml. So yes, after that, results, we are going to give model dot train. This is the syntax you should follow. Now we are going to give data path. Here we are going to give the config.yaml path. Now what is config.yaml? This is the file which have the location of train and validation set, which is stored in Google Colab directory. Now you can see, if I open this Google Colab config.yaml, you can see here is the complete path for the data folder, for train images, for validation images, and the name of classes what we have in this project. We have one class only, which is a number plate, and we are going to implement that. So simply press here and paste the data. Now we have to set the epochs. We are going for testing purpose only. We are going to use 10 okay, it will take time, so we are going to take 5 epochs. Let us say 30 epochs. That's a good one. Now for validating results dot val, results equal to model dot val, and this. Now run the code, and you will see your training will start in no time. So these are the number of layers which we are which our model using. These are the arguments. 225 layers this model is using, nano version of this model using, and these 33 lakh parameters are there. And now you can see our training is running. This will take some time. So we have to wait for that. Our 20 box are complete. So wait just a minute. So our training is complete and our results will be saved in the run file folder. As you can see, our validation is also complete almost. Yes, our detector is trained. You can see in train 2 our F1 score. Here is our results.png file which shows everything you want to know about your training. And for seeing the predictions, so these are the predictions which are made on the training set. This is a number plate detection. On the validation set, these are the prediction results. This is a number plate. Zero point 0.6 means 60% accuracy. This is a number plate. Zero point 0.9 means 90% accuracy. Yeah, you are seeing that here it is not created an any bounding box. This is because we need to train our model on higher number of epochs. This is that due to that problem it was not showing any, and here it is 60%, 90% accuracy, 80% accuracy with 50%. Let's see some other predictions. This is 90% accuracy. This is with, here are all the images. Yeah, these are images, not, it is predicting here as a number plate, but actual number plate is there. So yes, this is due to the smaller epochs training. If you can train it on, I think on 100 epochs, then it will work fine for every image. Here it is also not working. So yeah, this issue will be solved by training it on larger epochs. So yeah, that's how you can create a custom object detector using YOLO model. So that's it for this video. Please do like, subscribe the channel. Thank you.